everyone, this is Professor Benjamin, and as I promised you, here is my lecture on water. We covered a lot of this in class, but some of it I want to go back over again, okay? So remember, this is, you can find this in the modules, this PowerPoint, so if you want to go back through these slides, you can do that. Okay, so we talked about Lake Chad. So Lake Chad, of course, is a lake in Africa, and there are numerous countries that pull off of water off of Lake Chad. Without Lake Chad, a lot of those countries will no longer have access to water. And the reason for that is because Lake Chad is a closed watershed, which means that if you look at this image back here, you will see here that Lake Chad does not drain to the ocean. Lake Chad right here is, the lake is filled up by rainwater, right? And then you can see it comes out. So you can see that the river system, or the watershed, right, with the river systems, and we learned about watersheds with the Audubon Society, doesn't go all the way out to the ocean. So that is what we call a closed watershed. So it only relies on rainwater. And because of overuse, you can see here from 1973 to 2001, you can see this huge issue with Lake Chad, which is that it's drying up. So that's a big issue. And these areas, or these countries like Niger and Chad, right? And the Central African Republic of Congo, and right? All these areas rely on this water. Even Nigeria does. I know Nigeria has a coastal area, but remember, that would be a desalination plant that they would have to put in. So really important. Okay, so we talked about this in class too the other day, which is that the ocean's water covers 70% of the Earth's surface. 97.5% is salt water, 2.5% is fresh water, and of the 2.5%, only about 0.3% is available to us. It's not frozen in glaciers, so we don't have a lot of water that's available for human use. We talked about the water cycle. There is a video in the modules that talks about the water cycle, so you want to make sure that you watch that video from the Khan Academy, and it gives you all the steps of the water cycle. So you want to, as you're watching it, you want to take notes to all the steps of the water cycle. So here it is. Here's the video. You want to make sure that you watch that video and take notes to all the steps of the water cycle. Okay, so make sure you do that. All right, watersheds. So the Audubon Society came in and talked to us about watersheds, right? And I'm going to include the two videos that they included about watersheds and why they're important. So in the announcement, you'll see the two videos from the Audubon Society that they showed in class, so you can take notes for those, okay? And as we talked about, Lake Chad is a closed watershed, whereas the Delaware River, right, the Delaware watershed eventually drains to the sea. Remember, it drains to the Delaware Bay, and then it goes out to the Atlantic Ocean. So a couple things. How do we use water, right? I think a lot of us know this because we use water on an everyday basis, but we use over half of the water flowing in Earth's streams. We use it for non-consumptive uses, and we use it for consumptive uses. So in non-consumptive uses, we use it for power or wastewater treatment plants or septic systems, right? Or to create, for tidal power, right? All of those things are related to non-consumptive use. But for consumptive use, we use it for irrigation, we use it to drink, we use it in industrial use. So water is definitely something that we need. Remember, all the water we have here on Earth is all we have. We can't like break down the like the hydrogen and oxygen bonds. This is what we have. This is all we have, and it just gets recycled through the system. So if you look at this graph, you'll see how water is used throughout the world. And as you can see, that the United States uses about 46% for industrial use, and almost exactly the same sort of percentage-wise in agricultural use. If you look at France, they use most of their water for industry. Colombia uses most of theirs for domestic use and for agriculture. And if you look at Indonesia, it's mostly used for agricultural production. So you can see that also in the US, we use a lot here for domestic use. So does France. Colombia uses 50%. And that's of this is economically why Colombia doesn't have, because they just don't have a really large industrial kind of economy there. So you can look at how water is used throughout the world on these graphs. Okay, I'm going to talk about a couple different, like we're going to go into like streams and oceans and estuaries. Okay, so we're going to talk about all the different parts of freshwater, like where freshwater is located. So the first place that fresh water is located is in streams and rivers. Streams, of course, and rivers originate in the upper reaches of the watershed, and the water flows down the watershed and merges with other streams, and gravity is what pulls those streams downhill. Of course, the slope of the land allows that to either happen faster or slower. And there are two really important things that I want to talk about in terms of streams. There are perennial streams and intermittent streams. Perennial streams or rivers are the ones you see around all the time, right? There's always water in those. The intermittent streams only flow at certain times of the year. And this is something really important for us to know and understand, because a lot of you may live or have seen what we consider gullies. So it kind of looks like this, right? And maybe this is even dried up. And you see kind of where you might see like where two sides are really steep on the side, and then there's like a dry bed in the center. And a lot of people are like, oh, that's cool. I'm going to climb down there, and or I'm going to camp near there. A couple years ago, there was a religious group that was camping in Yosemite, and not in Yosemite, in the Grand Canyon area. And what happened was this here, it rained way over here, up here, and there was a flash flood, and the water came rushing down. Do you see how this is flat here, over here? This is what we would consider a flood zone. So when this river gets tons of water in it, it's going to fill up this whole area here. But they set up their tents along here, and unfortunately they drowned. So it's really important, especially if you're an outdoorsy person and you go camping, that you make sure that you're aware that if you put your tent here, and that, because you're like, oh, here's the water, I'm going to put my tent here, that if it rains miles away, that rain is going to come rushing down the stream, and it could flood this area. So really important to remember. So we have that perennial and intermittent stream. The next thing that I want to talk about in terms of streams and rivers are what we call point and non-point source pollution. And Damien from the Audubon Society kind of touched on this, but he didn't get heavily into it. Point source pollution is from a specific location, such as a pipe or a factory. And one important thing that's not on this slide is that you can trace it back to the source, meaning that if there is a leak, we are able to say that person or that company is doing the job. So if it Exxon Valdez spill, we could trace it back to the ship, right? Or the BP oil spill. We knew it was coming from that specific well, and we knew BP owned that well, so that we knew that, right? Also, sometimes fertilizers we can trace back if it's a large farm. Down here, non-point source pollution is pollution that we can't really trace back to the source. So this is when we throw garbage on the ground, on the streets, right? And then it rains and it goes into those storm drains. We can't, like, if we find a bag of Doritos in the Delaware River, we can't say, oh, this person who was on 18th Street put this in there and we're going to go find that person. So point source pollution is a big problem because, like, people who leave their dog waste on the ground and then it rains and that waste gets into the water system and then it gets into the river system. Canada geese are a big problem for this, right? It's non-point source pollution. We can't be like, hey, you Canada goose, you did this. It is a big issue because we can't trace it back to the source. And a lot of our pollution comes from non-point source pollution, and that's a tragedy of the commons, right? Because we can't pinpoint who it is. We can't find them. We can't hold them accountable for their actions. And this is just an example. So this would be non-point source pollution, and this is point source. Because like this, whatever pollution goes down here, we can't really trace it back. But this, we can trace back to the source. Okay, lakes. So lakes is another form, typically of fresh water, and human use and impact. So we have definitely altered the quantity of the water in a lot of lakes because we divert the water to other places, right? Or we use it for irrigation. We might dam a river and then create a lake, and then we use that lake for water, like Lake Mead, which is used to pump water to Nevada and other places. Arizona, a lot of water in Arizona comes from Lake Mead. And so this is a big deal. Now, one of the things is we also alter the quality of the water in lakes and ponds, etc., through, of course, pollution, sedimentation, and nutrients. So sedimentation is when the rivers run into the lake, they bring with them a lot of sediment. So if we clear cut a forest upstream, and remember, trees hold the soil in place, the roots of the trees hold soil in place. If we cut down those trees, then there's nothing there that holds that soil in place. So when it rains, the soil then washes into the rivers and then it gets into the lake. And when we fill up a lake with a lot of sediment, the lake goes away. Or the lake needs to be dredged. You also might drive by lakes and you see a ton of plant life, like a lot of lily pads, etc. And they also cause lakes to dry up. And a lot of times that comes from something called eutrophication. Okay. And eutrophication is when we put fertilizers on our lawn and we use laundry detergent, okay, hair, shampoo, etc., that have sulfates in them, and nitrites in them. That gets into our waterway. And then what happens is it gets into the river systems and then it gets into lakes. And that is like fertilizers, especially, they're made to make your grass grow, right? So whatever is in the lake, if the fertilizers get into a lake, it's going to cause all that plant growth to grow more. And that's what we call eutrophication. So that is a big issue as well. The next thing I want to talk about is groundwater. And in one of my classes, we talked heavily about groundwater. In the other class, we didn't get a real big chance to talk about it. So I am going to pull up this image here. And what I'm going to do is we're going to come back to the next video, part 2 of this video. And I'm going to show you what an aquifer is, okay? And what the water table is and all that kind of stuff. So just click on part 2 for the next part.